And it's, what is it? It's Wednesday. We're talking about the ratio test and the root test. These are known as row tests for convergence of series of constants with all positive terms. And what does that mean? Well, if you want to show a series converges, let's say this, okay? Sigma u sub k, some rule, some function in k or some function in n, whatever it is, okay? Oh, we started early. And say you want to show that that converges, right? What you do is you set up rho is the limit as k goes to infinity of u sub k plus 1 over u sub k. Okay? That's a rho. That's a lowercase r in Greek, okay? Is that right with you? So when rho may or may not have a limit. Now there's three possibilities. If rho is less than 1, if rho is 1, if rho is greater than 1. The series diverges in this case, converges in this case, and the test fails in this case. Use a different test. Okay? You can also do this. By the way, we're saying for an infinite series, right? Say k goes from 0 to infinity or something. Question is, does it converge or not? Here's another row test. Sometimes the ratio test, things cancel out nice and the limits are easy and you can get one of these cases, 1, 2, 3, you're done. Sometimes we use the root test instead. What if you get the kth root, radical in other words, of u sub k? Same thing. That limit may or may not exist. If it's less than 1, we have convergence. If it's equal to 1, use a different test. If it's greater than 1, we have divergence. Okay? And so let's try some of these. Are you ready? Okay, these are two separate theorems. The ratio test theorem for convergence, the root test theorem for convergence. Okay? This is convenient when things cancel out in a ratio. This is convenient when you have weird powers you want to get rid of. It can be proven, but that's beyond the scope of this course, that when rho is less than 1, the series converges. Okay, we're just going to use the theorem. Okay? So let's say I wanted to, all right, let's use a series that we know. This one we know. Do we know whether it converges or not? It doesn't. That's the harmonic, right? 1 plus a half plus a third plus a fourth diverged very slowly, but it diverged, right? Okay, so we know the answer already. 20/20 hindsight. Let's see if we can use the ratio test on this and get the same result. What does the ratio test say? Take the rule, u sub k, make a ratio, u sub k plus 1 over u sub k. Well, u sub k is the rule. U sub k plus 1, what do you think I'm going to write? Plug in k plus 1 wherever you see k. So, go ahead. What should I write up here? 1 over k plus 1, that's all. Simple. It's just a composition. Put k plus 1 in place of all the k's. It may be more complicated than this, right? So what's the limit as k goes crazy? Does that limit exist? Okay? Limit. So that's a rho. What's a rho? Well, how do you evaluate a limit that's ratio? You want to see if it's bottom heavy, top heavy, equal degree, maybe L'Hopital, something like that, right? But how do you divide a fraction by a fraction? Divide a fraction by a fraction. Reciprocal, right? So is this the same thing? The limit as k goes to infinity of k over k plus 1? If I multiply by the reciprocal, the k ends up in the numerator, right? Well, that limit you know. What is it? Is it bottom heavy, top heavy, or equal degree? Equal degree, so leading coefficients. What do you get? 1. Bad. Why bad? Ratio test? Fails. It doesn't tell me one thing or the other, whether this converges or not, when rho is 1. So there are better tests for this. We already figured out that that diverged anyhow, didn't we? Okay? Alrighty. Right, remember, when the rho test gives you 1 in the limit, the test is not applicable, really. Okay? Alrighty. So that wasn't a good example. Fine. But that happens. You got to be familiar with that. By the way, this is also L'Hopital, right? What's the derivative of the top? What's the derivative of the bottom? So you get 1, right? You get the L'Hopital on these. Okay. What about one of these? Oops, it's a K. Okay. I'm using K today. Okay, so we know this one converges or not, don't we already? What do we know about this series? This is a P series where P is 2, and is that good or bad? That's good. P greater than 1 converges, right? Let's see what the ratio test says. Let rho equal the limit, as K goes crazy, of u sub K plus 1 over u sub K. This is u sub K. What's u sub K plus 1? 1 over K plus 1 squared, right? Again, how do you divide fractions? Multiply with the reciprocal of the denominator, so the K squared ends up on top, doesn't it? All right, can you tell me that limit? That's also 1. Dang, ratio test fails. Remember, how did we prove that this was convergent, by the way? It was a better test. We used this in the comparison test, though. This is one of our known series for comparison tests. So we proved this converges otherwise with a different test. Integral test. Remember, we get P integrals out of this, right? Remember, we know how to do an improper integral for P integral 1 over x squared? Same thing here. This is a P integral of P equals 1 if you do the integral test. Okay? And that improper integral diverged, so did the series. This improper integral converged in the integral test, so this converged. We already know this. That's not a good test. All right, how about this one? One over K factorial. Now, I mentioned the other day, we haven't proven this converges. We don't know what it converges to, but I did mention the other day, it does converge, by the way, to E. Okay? If you start actually at 0. What's 0 factorial? 1. You can start at 0, right? If you start with 0 and add up infinitely many multiplicative inverses of factorials, you're going to get E. All right, so I know this one converges. Does the ratio test tell me this? Now, you can't use the integral test on this, because how the hell do you integrate factorials? I don't know. You don't. Okay. We used this. I just sort of threw it at you as a series I could use in the comparison test to show convergence by comparison. But we just threw it at you. Can we prove it now? I think we can. Let rho equal the limit as K goes wild. Of what? U sub K plus 1 over U sub K. U sub K plus 1 over U sub K. Now remember, if this limit is less than 1, we have convergence. If this limit is greater than 1, we have divergence. Why does that make sense? Because what we're doing is really we're comparing every term to its next term. If for infinitely many terms, the next term is smaller than the previous term, we have convergence. If this limit is less than 1, it means that this is less than this, right? When is a fraction less than 1? When the numerator is smaller than the denominator, right? So if we get a limit less than 1, I'm not saying that's what it is, but let's say we do. That shows convergence because we're checking infinitely many terms, a term and its next term. For infinitely many terms, is the next term always smaller than the previous term? If that's true, we have convergence. That's why this works, okay? Well, what is this limit? Nobody knows the limits I've seen. Nobody. What do you do with this? Okay, so the limit as K goes to infinity of K factorial over K plus 1 factorial. This limit is easy if you realize that that reduces. What's K factorial into K plus 1 factorial? What's 5 factorial into 6 factorial? K. No, not K, careful. K plus 1. Right? If the numerator was 5, right? 5 factorial, and the denominator was 6 factorial, isn't 5 factorial 6 times 5 factorial? Isn't 6 factorial 6 times 5 factorial? Isn't this the same thing? K plus 1 times K factorial? If that's 5 factorial, and that's 5 factorial, that's 6. But 6 times 5 factorial is 6 factorial. We're saying a factorial and one more, right? 5 factorial over 6 factorial would be what? 1/6. 7 factorial over 8 factorial would be what? 7 factorial over 8 factorial would be what? 7 factorial, and 8. 1/8. Right? 9 factorial and 10 factorial would be what? 1/10, and so forth. So k factorial over k plus 1 factorial is 1 over k plus 1. Right? The factorials cancel. So what is that limit? It's 0. Therefore, what? Converges by what? Ratio test. Because why? Rho is less than 1. Okay? That's how the ratio test works. And we're going to need that a lot next week when we're going to try and find out where power series converge. Okay, remember what a power series is? It's a series of functions. So we can plug in different values of x and see if it converges or not. Yeah. When we plug in particular values of x in a power series, we get one of these series. And we can prove convergence or divergence this way. All right, so this is just warm up for next week. Don't forget Friday. What's going on Friday? This week? Test, what's tomorrow? Groups, right? Okay. Okay. Not going to be here tomorrow? That's not a good day to not be here. Okay, that's such is life. Okay, here we go. Let's try some more. What's another good one? Let's see, that didn't work, We tried that. All right, how about this one? K goes, I guess, from 0 to infinity. And the rule is 4k minus 5 over 2k plus 1 to the k. Now here you have to have some intuition in that the ratio test isn't going to help. The problem is what? What's different here? What's different here? There's a k in the exponent. I want to get rid of that. So we use the root test. Remember, we have 2 row tests. There are a lot of row tests. We only need 2 of them. All right? If rho is less than 1, we have convergence. If rho is equal to 1, the test is not applicable. If the rho is greater than 1, we have divergence, but we can do that by ratio or root, the kth root of the rule. Okay? So, what are you going to let rho be now? Rho is the limit as k goes wild of what? The kth root of this mess. What's convenient about this? The exponents cancel. Isn't the kth root really raising to the power of 1 over k? Is that what we're really doing? And how do you take the power that's 1 base and 2 exponents? What do you do with the exponents? They multiply and they cancel out to 1, right? So really, this is what I'm taking the limit of. Well, guess what? Is that top heavy, bottom heavy, or equal degree? It's still a rational function. So it's still L'Hopital. What do you think the limit is? 2. So what does that tell me about the series? Therefore what? Diverges by root test, because rho, what's bad about the root test? When is the root test bad? Greater than 1. That's it. So use the ratio test or the root test as needed. Okay. How about this one? Ready? K starts at 1, goes to infinity. And we've got k factorial over k to the k. By the way, don't forget, the first thing you usually ask is, does it pass Cauchy? Does it? Sure it does. Why? Because it's way bottom heavy. This is the most bottom heavy you can get, right? Remember NN FEPL? This is second, this is first. All right, so yeah, passes Cauchy. Okay, good. Now, what test would you use here? Root test? Yeah, you could root this, but that'll mess this up. Yeah. If I only use the root test if it cancels everywhere, right? Yeah, that's not useful. You could try it, see what happens. It might be, but I think I've tried it. It's not. Yeah. How about let's try the ratio test? Let rho equal the limit as k goes crazy of. All right, now it's u sub k plus 1. What would I write for u sub k plus 1? Or it's u sub k plus 1 over u sub k. This is u sub k. K plus 1 factorial over k plus 1 to the k plus 1. Now that's u sub k. Now u sub k plus 1. I want to divide by u sub k. But remember, how did we divide by u sub k always? We really didn't. What do you do instead of dividing? Multiply the reciprocal of this. Okay, so k to the k over k factorial. Okay. So now the ratio test is useful if things cancel out and it's an easy limit, therefore. So does anything cancel out? K factorial into k plus 1 factorial is what? K plus 1. Remember, we talked about this. 5 factorial into 6 factorial is 6. 9 factorial into 10 factorial is 10. K factorial into k plus 1 factorial is k plus 1. But k plus 1 and k plus 1, k plus 1 and k plus 1 cancel out too. K plus 1, well, right. We cancel out one factor of k plus 1, right? So it's only, right, so if we divide the k plus 1 that's left from the factorial into the k plus 1 to the k plus 1, we leave the 1, we lose the 1, right? Okay, so this is what we get. The limit as k goes to infinity of k over k plus 1 to the k. How do you evaluate that limit? Realize that limit is an indeterminate. What does that mean? Forget the k in the exponent. What would that limit be? Forget the k. Say that k in the exponent wasn't there. What's the limit of k over k plus 1 as k goes crazy? 1. So this limit is of the form 1 to the infinity. K is there, right? Well, how do you deal with 1 to the infinity? Hopefully you can get this to look like a L'Hopital. We've seen this before. Is it? It might be. Does it have to be? No, it's indeterminate. It doesn't have to be 1. Right? Remember, we've had a number of weird cases, like infinity over infinity, you would think is 1, but not always. 0 over 0, we think is 1, but not always. 0 times infinity, you would think is 0, not always. Infinity minus infinity, you would think is 0, not always. Those are all indeterminate forms, and a lot of them can be rewritten to use L'Hopital. So, let's do that. Let's go on our scratch paper here. I want to find the limit, as k goes crazy, of k over k plus 1 to the k. And remember the trick. We've done this before. What if I call that thing y? I'm trying to find the limit of y as k goes 1. What do you want to do to this k? I don't want it here. Where is it nicer? Down. How do you bring down exponents? ln. What if I ln both sides? Okay. Now what? Well, if I take the limit as k gets huge of ln y, which is this, if I can find that limit, then I'll just raise it to the power v. If ln y goes to 2, let's say, I'm guessing, I don't know if it does. Let's say this goes to 2. What does y go to? How do you get rid of ln? E to the. So if I can figure out the limit of ln y, I can figure out the limit of y. And this is what they wanted, right? Remember, this is the thing I'm taking the limit of for the ratio test. I want to know if it's less than 1 for convergence, greater than 1 for divergence, or equal to 1, test fails. So how do I do this limit? Can I do this limit? We've seen this before, you don't remember. What if I wrote it this way? Is that the same thing? Instead of the k in front, it's 1 over k here. How do you divide by 1 over k? How do you divide by 1 over k? Multiply by k, right? Same thing? Can you find that limit? What's the limit as k goes wild of this? Well, what happens to k over k plus 1 as k gets huge? Goes to 1. What's ln 1? 0. What happens to 1 over k when k gets huge? It goes to 0. When you have 0 over 0, that's when you use L'Hopital. What does L'Hopital say? If you can't do the limit as is, but you get 0 over 0 or infinity over infinity, take the derivative of the top separate from the bottom, do two separate derivatives, and try the limit again. It might be easier, and it might actually give you an answer. It might diverge. That's an answer too, right? Okay, so what's the derivative of ln u? 1 over u du. All right, so 1 over u, I can't write. 1 over u is this, right? No, damn it. I'm just going to flip u. This is u, so I'm just flipping it. 1 over u, right? Times the derivative of u. Well, how do you take the derivative of a quotient? Quotient rule, right? So low d high. I can't write today. Low d high minus high d low over low low. Why can't I type today? My tablet's skipping. K plus 1 squared, right? That's the derivative of the top. What's the derivative of the bottom? Right, this is k to the negative 1, so the derivative would be negative 1 k to the negative 2. In other words, negative 1 over k squared. And can you take that limit? Well, it looks worse, but things simplify before you take the limit. All right, let's see. What's this numerator, really? That's just 1. Okay. What is k plus 1 into k plus 1 squared? K plus 1 in the denominator, right? So this is really 1 over k plus 1 times k. What's this? How do you divide by this? Multiply by the reciprocal. So it's really this. The limit as k goes to infinity of negative k squared over k times k plus 1. Isn't that what's left? That went here, right? That went here. And that canceled with that, leaving that. And this was 1. So there's a 1. But you know this limit. You can do L'Hopital on this too, because now it's infinity over infinity. But don't you know this limit? Top heavy, bottom heavy, equal degree. Which is it? It's equal degree. Leading coefficients give you negative 1. So what did we just show? We showed that the limit as k gets huge of ln y is negative 1. So what's the limit of y? E to the negative 1. Why is that significant? Let's go back here. That's this limit. What happens when the ratio test gives me a limit of 1 over e? It converges because that's what? What are you worried about for rho if it's what? Less than 1. That's less than 1, isn't it? Isn't e 2 point something? 1 over 2 point something, it's got to be less than 1. Okay, so therefore, converges. There you go. Therefore, convergent by ratio test. Ratio, why am I writing ration? What is that? Test. Because rho is less than 1. In fact, it's 1 over e. All right, you've got to be able to do limits like this. They're going to ask you limits like this. This comes up. That's about as crazy an indeterminate form as you're ever going to see. Okay? That's about as crazy an indeterminate L'Hopital question will become. They would probably put this in part 1 and would say, what's this limit? They could say this. What's the limit? What's the limit as k goes wild of this? Okay? But you should recognize it. Look, what did we have? We had the limit as k goes wild of k over k plus 1 to the k. But we encountered this before. I don't know if you remember. We had the limit as k goes to infinity of 1 plus 1 over k to the k. We've seen this one before. This was e, and this one's 1 over e. Why must it be so? How is this related to this? This is the definition of e, by the way. It's the reciprocal, right? Multiplicative reciprocal. Multiplicative inverse or reciprocal, right? So, look, if I add these, if I want a common denominator, this is k over k, don't I get k plus 1 over k? We've seen this before. Okay? Now, we haven't seen it in this form. This is the reciprocal of that, right? So if this limit goes to e, this limit goes to 1 over e. We've seen this, though. We haven't seen it that way. We saw it this way. Why? Where does this come from? Compounded interest with infinitely many compoundings, compounding continuously. This is the banker's problem. This is where e comes from. This is where p equals p0 e to the rt comes from. E to the compounded continuously interest. We've seen that limit before. Way back when we did L'Hopital, we did a limit like this, in this fashion, all this craziness. Except this is worse because it's the reciprocal, so this is a mess. We did it without the reciprocal. It was a little bit easier, but we still got e out of that. Okay? You've got to recognize these limits. They come up a lot. By the way, vice versa, if, let me see. You should really know 4 limits of this form. Let me see, how should I write it? This one goes to 1 over e, this one goes to e. How about this one? What do you think this one goes to? The limit as k goes to 0 of 1 plus k to the 1 over k. What do you think that is? Nope. Realize that this limit and this limit behave exactly the same way because you're dealing with the same numbers. As k goes to 0, 1 plus k goes to 1. As k goes to infinity, 1 over k goes to 0, but 1 plus 0 goes to 1. This goes to 1, this goes to 1. As k goes to infinity, k goes to infinity. As k goes to 0, 1 over k goes to infinity. If you do crazy stuff like this, what we did here, to that, you get the same answer. All right? So if the limit at infinity for this is e, the limit at 0 for this is e, because it's the same numbers. Likewise up here.
And did they figure this all out?
Who figured it out? What?
Just let's see.
Well, these numbers come up. Remember, who is it named after? E is named after Euler, because you spell Euler with an E, not an O. It's not a football team, okay? It's not the Oilers. All right? So he stayed up all night doing stuff like this. That's why they named it after him, okay? He did this stuff. What if, let's see. Could I change this? What if I did a K? Could I rewrite this one? If I went from K goes to 0, of the reciprocal of this and the reciprocal of that, I would get the same thing. Yeah.
Do you mean to say Einstein?
Yeah, notice what I did here is I basically did the reciprocal of this, right? All right, I don't want to get too crazy with this. You should be able to do these limits with L'Hopital. Let's not get stuck on this. All right, what else can we do? How about this one? Wait. Okay, how about this? What if I want sigma as k goes from 1 to infinity of k over k plus 1 to the k squared? Now the ratio test isn't going to do much for me, is it? Do you want to try the root test? Let's try the root test. Let rho equal the limit as k goes wild. of the kth root of u sub k. Yeah, okay, hang on. So what is it then? What's in the exponent then? It's just k. Okay. But don't we know this limit? Is it this? Is it that? It's the same one, isn't it? Same one. Ah, it's the same limit. All right, so we don't have to do it again. We know it. If you recognize this limit, just write it down. Everyone on the AP is supposed to know this limit. Everyone on the AP is supposed to know this limit. It comes up a lot. If you know these two, you're in business. Okay? So this comes up a lot, this comes up a lot. Guess what? It just came up again. So what's your conclusion? Therefore convergent by ratio test. Oh, sorry, it was a root test, you're right. By root test, because rho was again less than 1. In fact, it was the same rho. Okay. So what would you do in this case? Sigma as, all right, is this the one I wanted? Okay, as k goes from 1 to infinity, of k factorial squared, holy cow, times 2 to the k, okay, over 2k plus 2 factorial. Holy cow, are you kidding? And hint, 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 what test are you going to use? Which ratio test? I'm sorry, which row test? The ratio test. Yeah, I gave it away. All right. Right, because there's a bunch of fractions here. With the ratio test, things hopefully will cancel. All the factorials, all the powers, right? That's the idea. So let rho equal the limit as k goes crazy of, let's see, how do you write u sub k plus 1 if this is u sub k? This is the discrete function u sub k. How do you write the discrete function u sub k plus 1? K plus 1 factorial squared times, what about this? 2 to the k plus 1 over, what about this? If I plug in k plus 1, what do I get? Yeah, I got 2 times k plus 1 is 2k plus 2 plus 2 is 2k plus 4. Ah, okay. Now remember, it's a ratio test, but instead of dividing, what am I going to multiply by? The reciprocal of this, right? So 2k plus 2 factorial over k factorial squared over k 2 to the k. Does this limit exist? In fact, is it less than 1? That's what I want to know. All right, well, holy mazzoli. How are you going to write that out? Well, let's see. Let's see if I can make this obvious. The numerator is really k plus 1 factorial times k plus 1 factorial, right? And this denominator has k factorial times k factorial, right? So what does k factorial do to one of these k plus 1s? It's just k plus 1, right? 5 factorial into 6 factorial is 6, right? Wherever it ended up, in the numerator or denominator, wherever the k plus 1 was. So this is a k plus 1 and this is a k plus 1, gone, right? What does 2 to the k plus 1 and 2 to the k do to each other? This is just going to be just 2, right? How do you divide 2 powers of the same base? You subtract the exponents. K plus 1 minus k is 1. That's just 2. Okay. How are these two factorials related? I'll give you a hint. This is sort of like 6 factorial and 8 factorial. Right, isn't this 2k plus 4 times 2k plus 3 times 2k plus 2, what's missing? Factorial. So this is left when you cancel this. K plus 1 is left when you cancel this. K plus 1 is left when you cancel this. 2 is left when you cancel this. So let's do this limit. 2 times K plus 1 over 2K plus 4 times another K plus 1 over 2K plus 3. And that limit, you know it. Because these are top heavy, bottom heavy, or equal degree. Both of them. Equal degree, so leading coefficients. What's this limit? As K goes huge, this becomes 1/2, and this becomes, what's 2 times a half times a half? 1/2. So, is this a good row or bad row? Good row, so say so. Therefore, convergent by, this was ratio, test, since rho became less than 1, or you might even say rho is 1/2, whatever. You can say that too. Okay, is this terrible? This isn't terrible, right? Okay, let's try it again. How about this one? What if I go for k goes from 1 to infinity of 2 to the k over k cubed plus 1? Want to do ratio test? Okay. So let rho equal the limit as k goes to infinity. How do you write the discrete function u sub k plus 1? 2 to the k plus 1 over k plus 1 cubed plus 1 times, what goes on top? K cubed plus 1 over 2, wait, this is cubed, right? Whoops, sorry. This is a 3, okay, over 2, sorry, 2 to the k. Alrighty, and so can you simplify this so it's easy to do the limit? Let's see. There's a 2 on top again, right? That's nice. So this is nice when you have exponentials. This is nice when you have factorials, right? All right, so you got a 2, and then you got a k cubed plus 1 over k plus 1 cubed plus 1. Well, what kind of limit is that? Top heavy, bottom heavy, equal degree. If you actually cube it, damn it. I put a 2 there again. Okay. If you actually cube this out, what's the leading coefficients? So what? Equal degree, and what are the leading coefficients then? This will end up with a k cubed in front. This ends up with a k cubed in front, right? So the limit is 2. So is that a good row or bad row? Bad row, say so. Therefore, divergent by ratio test because rho was too big. So remember, if you do a root test or a ratio test, and rho is 1, pick a different test. This test doesn't tell you anything. It doesn't apply. It doesn't tell you convergence or divergence. I don't know. Use a better test. If it's greater than 1, divergent. If it's less than 1, convergent. And that's all she wrote for today. Is that enough? Did we burn out some brain cells or what? Yeah? Okay. All right, so let's stop this here. Just stop the madness.